length, that arc length was radius times theta, and then the area is 1/2 radius squared theta. Theta will always be in terms of radians as you're going through these.
Is that arc? No idea.
Theta.
Oh.
Okay. So in that first problem where they gave you theta at pi over 2 and an r of 12, well, that means your arc length would be 6 pi. And that means that your area would be 144 over 2 times pi over 2. So that's 72 divided by 2, you get 36 pi something squared. Okay. And then if they just put it in terms of degrees, I won't make it in terms of degrees, because when they're talking about this, we're going to keep everything in terms of pi, so that would just be the radian measure for those.
So I didn't use the pi over 2, I just used it.
Oh, and then you flipped it back into radians then? That's cool. If you want to do it that way, that's fine. It's just, remember, because the theta stuff is just, it's just quicker with the fractions, that's all.
I didn't know that's what it was saying.
Yeah, that's all it is. Okay, that's all that is. Yeah.
With trig identities, are we going to need to know those?
Yes.
Oh, okay.
Come on, shoot.
Oh, boy.
Did I hear you say cheat sheet, Mr. Leonard?
I just know.
Sine squared plus cosine squared is 1.
Oh, right.
Then we had, what was it, secant squared minus 1. It's cotangent, I believe. I believe that was the 2 of them, wasn't it? I'm trying to remember off the top of my head.
No, you can't do it. Well, that's one of them, but that's not the one that's raised.
Nah, that first one. Come on now.
It's 1 plus tan squared equals secant squared.
1 plus tangent squared. Okay, I had it backwards.
So if you don't know it,
Sorry about that. I had it backwards.
But isn't it the same thing anyway?
I had the cosecant and secant backwards. So
I think we should do this or like little. That's what I'm saying. It's not on here.
I haven't decided what I'm going to give you guys, if anything, yet.
If anything.
And then the other identities are just, you sine, tangent, sine over cosine. Oh, I thought you were done. Oh, nice. Correct. So as you're going through these, I'm trying to remember, on the chapter test sheets, there are a couple of identity problems on there. Well,
found it.
when you're dealing with the trig stuff, the first things we looked at were the right triangle stuff we looked at yesterday. And then that had radians to degrees, and then you had reference angles. That was kind of like a big first chunk. And then you had law of sines, law of cosines. And then when it gets into trig, the chapter 14 stuff, that's when we started doing trig identities. We did graphs, and we did solving of equations. So I'm going to go over kind of all of that today. So when I'm looking at the trig identity here, there is, we have a verify one in here. Where is it? I'm looking at number 10 on this one. Actually, you know what? Where it says simplified the tangent pi over 2 minus x, and they have that one you can't do because it's a negative angle or a half angle. So cross off 7. I didn't get a chance to cross that one out. Number 7 on the chapter 14 part here, number 7. Cross that one out. But this cosine squared over cotangent squared, we can simplify that. Okay? We can simplify that. Cotangent squared is what?
Oh, something.
Cosine squared over sine squared. So if I'm dividing by cotangent squared,
What did you do with the x's?
remember I always just didn't write them?
Oh, yeah.
Wait,
It's just laziness.
was that
And you get that. You just get sine squared for that problem. Because you're dividing by cotangent, which means you're multiplying by tangent, so I just wrote it as tangent right off the bat. Okay.
Which one is it?
I am on number 9 on the chapter 14 part, right there. Okey doke. Actually, we got to cross off 8 as well. We didn't do one like that, so don't worry about 8. So 9 was a very quick, forward, simplify one. If I look at the verify, yes, ma'am. You need to know those. I haven't decided what I'm going to put on or anything yet. I haven't gotten that far. I'm still finishing the final. Do I need to show you guys how tangent times cotangent equals 1?
No.
Okay. Oh, wow, you can't do 12. That's a double angle. And let's see. Tangent squared plus 4 is secant squared plus 3. Well,
Oh, so it'd be like a 1.
so is it tangent squared, secant squared minus 1?
Yes.
So there's your verify.
So like, how do you put that on a multiple choice test? Because you can't like write out your verification.
You're right. So think about this is when you have simplified verify, it's going to be tough to have a verify, wouldn't it? But you can have what is the simplified version of a trig identity, right? So I can do something, let's see, what's the other, there was a problem on here that I like. I think on like number 8 on the 14C. This might be a little bit more complex because this takes a little bit longer. I mean, to do something like this, you could probably figure out what's the simplified version of that. It's actually really a lot more of a nightmare than it probably needs to be. Let's say it was minus 10. Wow, I really gave you guys a tough one here, didn't I? Let's pull this up. That's no, it's not so much that. It's just some of these things get to be really. Let me show you this. Let's go back to something like this. Can you take? I'm thinking more along the line of complexity of this. Can I simplify that? Can I figure out a simplified version of that? Okay. Now, what happens here, excuse me, is that in order for us to simplify that out, notice that you have secant, you have a secant and a cosine. Is it secant just 1 over cosine?
Yeah.
So in what I would look at is that this is 1 over cosine squared minus 1, correct? What's
One up here, secant squared.
so 1 over cosine squared is the same thing as what?
Secant squared.
So that's secant squared minus 1, which is
Tan squared.
Yeah.
secant is 1 over cosine. Cosine times cosine is cosine squared.
Wait, how do you find solutions?
What's that?
How do you find solutions?
You solve for x, solve for theta. You have to plot it into the quadrants. Excuse me. The other one that we had. If I look at something like that, where I have, oops, sorry, this is here. Cotangent times the quantity cosine tangent plus sine. if you had to simplify that,
Wasted
and as you multiply through, you're gonna, first thing you need to do is distribute. You okay with that?
Okay, so you wouldn't like want to simplify anything, you can't simplify with different parentheses, you have to.
If you simplify with the simplify, if I can talk, what happens here, you get cotangent, cosine, tangent, plus cotangent, sine, just by distributing. If I simplify it out, it really doesn't help me anything here, because what happens in that first group?
Cotangent, yeah, they can't see.
That drops, right? Now, I get cosine then, plus, well, that's cosine over sine times sine. What happens there?
Signs dropped out.
The sines drop, and what's cosine plus cosine?
Cosine squared.
No,
Oh, shoot.
since I'm adding, my answer, a simplification like that, that's a very easy thing to come up with for a multiple choice. You know what I mean? It's not that you have to verify, because the verifiers are a pain. It can be an absolute pain, but can you use some of the very simple properties of just distributing, simplifying of a fraction to go with it? Now, what Erin did, she said it was cosine squared. Well, guess what one of the choices on that would be? Cosine squared.
So that
She would get it wrong.
fail.
And she's going to fail, and her life is going to be miserable.
Take again.
Yup.
Nothing
Nothing wrong with community college. I went to one.
No job.
It can be.
It's really smart to go there first. Save yourself thousands of dollars. Erin, I hope that your life is going to be better. It's not like one of those direct TV commercials where if you didn't do this, then you do this, then you do this, and then all of a sudden you're shaving your head and selling your hair because you ran out of money in Vegas.
Well, you should have gotten direct TV.
Correct. I'm Rob Lowe, and I'm creepy Rob Lowe.
I got that. I got a 9
Last one of something like this, just
I'll show you.
I'm trying to show you guys ideas of or not say non, but complex, but not going to take forever to do, okay? Because there's only so much time.
And you run out, you fail.
Destiny's gonna go you cry. Again.
So now in this one here, if I have sine over cosecant plus cosine over secant, how can I rewrite that right away?
One, maybe, probably not.
Well, it is, the answer is 1.
Oh,
The whole
really?
thing?
Yes.
Okay, well, there we go, we're done.
Watch what happens.
Oh, I know, I know sine squared.
Isn't,
plus-
Destiny, help me out here.
Yeah, you flip them. I lost it. I actually lost it.
No, you got it.
No,
It's sine
over
over sine.
sine plus sine, and then yeah, it's cool. You bring the sign up. Yeah, you bring this up.
It's equals 1. Go team.
Do it!
Not gonna fail.
You got it. You got it. You got it.
Wait, check, I thought that cosecant was 1 over sine.
It is. So when you divide by 1 over sine, you're multiplying by the reciprocal, so it becomes sine squared.
What?
It says not 1?
Or you can just put it, you can't really do that with a calculator.
Hey,
You can put it
Mr.
in first
Murphy.
function.
Can we do the circle?
Why is
like
it sine divided by cosine 1?
No, sine divided by cosine isn't 1.
It's like you could cancel out the
Wait, now
sine,
what did I get?
and you have sine.
Circle. The unit circle.
Oh my.
The unit circle is one of the most important things that we discuss the entire school year. It is, or what hour?
Oh, it's divided by.
It was a 6-hour.
It makes sense.
Hunter, Jack, Lena, somebody else, they all wandered in, and they were walking by the 6-hour algebra class, and I asked those guys, if you could go back to last year and tell yourselves one thing that you need to make sure that you've got a really good hold on to be able to reuse in pre-calc, what would it be? and a lot of them just kept saying trig. The idea here with the right triangle trig stuff that we did in the unit circle was all based off of two triangles. 30, 60, 90, and then the 45, 45, 90. Everything is built off of those. If you remember how to set up those two triangles, the unit circle itself is a piece of cake. Solving equations using trig becomes easy because you know how to place things into the circle. And it all stems from these three angles. 30, 45. We got internet!
Oh, nice.
So at 30, it's one. Oh. Your ordered pairs, how do they go? Does it go cosine sine or sine cosine?
Sine, cosine.
Sine,
Cosine, sine.
sine,
Sine,
cosine, sine.
Which is it?
Cosine,
sine, cosine.
Cosine, sine.
Tangent, cotangent.
Cosine.
It's tangent, tangent.
Shut up.
Did you get that?
Hey, remember when I beat you in every class?
Shots fired.
Do not mess with that.
All right, so
Because of that.
when you're placing these things through, your 30-degree angle represents the pi over 6. Remember how that worked? The 30 goes to the pi over 6, the 60 goes to the pi over 3, and then the 45 was the pi over 4. So those were easy to remember. Now, your quadrantals, when you're talking about zeros, think about your ordered pairs. Just over this.
I tweaked so bad that I remembered everything.
You had 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now, if you forget what comes first as far as your ordered pairs are concerned, this is how you remember. You take out your calculator and you type cosine of 0.
Is it?
It's one,
It's like one.
So what comes first?
cosine,
Cosine.
Who said that?
It was cosine, sine. I told you guys.
Does that make sense, guys? Because I'm not taking this away from you. So if you type in, if you forget which ordered pair goes first, just type in cosine is 0, because you know the ordered pair here goes 1, 0. So if it gives you 1, you know cosine goes first. Cosine of 90 should give you 0. So it helps you to remember which one goes first. So now you have cosine, root 3 over 2, sine, 1/2, root 2 over 2, root 2 over 2,
whoa.
and then this is 1/2, and root 3 over 2.
Is that a 3?
Yeah.
Like next to the 2 on the first one?
Those are the only things you need to know, because everything else is mirrored into the other quadrants. Yes, ma'am?
You want us to know like the pi over 4 and pi over 2 stuff too, or is that not?
Yeah, those are your quadrantals. Your quadrantals are at pi over 2. This is pi over 2, pi, 3 pi over 2, 0. Pi over 4 is your 45s. Okay? Yes, ma'am?
Okay, so I know it asked about like the positive and negative functional labels. Like I get them when denominators like 4, 2,
Uh-huh.
12, but I don't get how you do it for like 5.
Which problem is that? Is I'll do one.
34.
30. Read it to me, please.
18 pi over 5.
18 pi over 5. You need to find a positive and negative coterminal angle. So if I'm looking at this, what I'm first going to do is figure out how much pi is that. Well, it's 3 3/5 pi. Are we okay with that?
Yeah.
Is 3/5 more or less than half? It's more. So basically what I'm doing here is that I know that it's going to spin around 1 little, 2 little, 3 little pies, and a little more than half. Okay? So I know that it's got to drop to the 4th quadrant. If I know, hey, we missed you. No, we didn't.
No, we didn't.
So we know that it drops into that fourth quadrant.
Wait, I'm confused about that license.
So if I want to get a positive
Oh, never mind.
coterminal angle, I have to basically back it out because it's more than 2 pi. So what I'm going to do here is I'm going to subtract 2 pi. If I subtract 2 pi, I'm left with 1 3/5 pi, aren't I? There's your positive coterminal angle.
1 3/5 pi.
Yep. 1 3/5 pi, because all I'm doing is backing out 2 pi because this is more than 1 full revolution. So the positive would just be coming around
And then negative.
1 3/5, so that would just be 8/5 pi. The negative is just, well, if I'm starting at this and I drop down, it would only had to go down 2/5 to hit that. So it would be negative 2 pi over 5, 2/5 pi. That's all it is. It's you do the exact same thing as we did with the 12ths, the 4ths, the 6ths, the 3rds, as you do with the 5ths. It's just a 5. Sir.
So you subtracting the 2 pi with the
Positive, because I'm overwhelmed.
and then you subtracting the gas.
Yeah, you can do it that way if you want. Yeah, Austin.
For the 33 in that same section, I was just wondering why the negative coterminal angle is negative 13 pi over 4.
This is within, since you're starting within 1 revolution positive, or within 1 full circle positive negative, they had to spin it out again.
Okay, so it had to go completely
Yeah.
out, okay.
Yeah, that's why.
Don't you have like add 2 pi over add 2 pi?
Yeah. Because when you're within 1 revolution, you're adding and subtracting 2 pi. If you're more than 2 revolutions, then you got to back it around a couple of times. That's all.
Okay.
That's the weirdness of it. Okay.
So the negative coterminal angle might still have to add 2 pi.
Sometimes, yeah.
And for the positive,
Yes, sir. I don't know where the computer set up. Finding the exact values. We did a bunch of these, a lot of these. When they're spinning them around, you have to basically figure out what is their coterminal angle. It's to get the reference angle. When you see negative 765, what do you think the reference angle is going to be?
45.
45. Okay. Now, it's 45 degrees into the 4th quadrant. If it's a 45, 45, 90, here's theta, 1, -1, and root 2. Cosecant is the inverse of which trig function? Sine. It's the inverse of sine. Sine would be opposite over hypotenuse. Cosecant would just be hypotenuse over opposite, so this would be negative root 2.
Isn't this the one that's like tan positive, like, you know, with the usual ones?
That's when you're solving the equation.
Okay.
Okay?
Oh, negative.
This negative.
Where is the negative one located?
It goes down.
This is 4th quadrant. Yes, ma'am. No, no. Good question. You're gonna have to find anything that's not on a triangle? No. Next year you'll do half angles. You'll find like 15 or 120. Oh wait. There's, yeah. Right. Yes.
So when they're in like the 4th quadrant, how do you know which side?
Remember, theta is always backed in. Theta will always be backed into the origin. That means this is always going to be positive. This is negative. Think about your order.
That is,
If this over here, aren't they, isn't this negative and this is negative?
okay, so it's just like, or
Just remember your ordered pairs. Remember how your ordered pairs work. Plus, plus, minus, plus, minus, minus, plus, minus. And that's how cosine and sine work also. Here.
So cosecant's the in the sign, right?
The inverse of sine, yes.
So why is it negative square root?
Because the hypotenuse was root 2, the opposite was negative
Well,
1.
why is it positive? Why is it negative?
Because what is 1 squared plus negative 1 squared is 2. The square root of 2 is here.
Okay, she just wants like.
The hypotenuse is always going to be positive because it's distance.
Okay.
Because the hypotenuse is finding you the distance between where the ordered pair is laying. Okay, that's why. The hypotenuse will always be positive. Your x and y values will notice because that's going positive x, negative y. All right. When I go to this one, yes, Izzy?
Do you think like the test is will be like in order of chapters or?
I don't know. I haven't finished sequencing it yet. When I have this one here, we have to spin around to figure out what our reference angle is. Let's see.
Something.
Well, if this is, if I'm moving around, let's see, that would be 180, 360, 540. My reference angle is 30 degrees. So I'm finding the sine value of 30 degrees, which is opposite over hypotenuse. So it's 1/2. Okay.
You say it was the answer to that one?
1/2.
Okay, good. Whoa.
Find the secant value here. Remember, these are your ordered pairs. These are your ordered pairs. You went -6 on the x, and your y was root 13. You still have to figure out your hypotenuse. So your hypotenuse is going to be 36 plus 13, which is 49. Square root of 49 is. So the secant of theta is going to be hypotenuse over adjacent, so it's -7/6.
How'd you know where to put each one?
X and Y.
So,
X
Okay,
goes
I-
across, you know,
What's
Y
X,
goes
Y?
up.
Where did this?
Cosine sine.
Okay, so then how does that make you know that root 3 is like that?
you're hearing me.
Because this is your X and Y. I went -6x, and I went up root 13.
Wait, where did you get this?
Okay, so the sine, so
Pythagorean theorem.
you just use Pythagorean. Oh, okay.
-6 squared is 36. 36 plus 13 is 49. Square root of 49 is 7. We did some of those yesterday. Don't forget the trick when you're looking at the code, when you're something like this one, you gotta remember to pull out the 3 in front of the theta because of the shift there.
Can we graph line together?
I want to do an equation real fast before I go to the graph. Because these are, I want to do these real quick. We're trying to get through a couple of those.
Is this in packet B?
The one you got, was it, yeah, the one the other day. So let's see here. Which one am I using? Wow, these are all. Oh well, let's do this. Let's start with this.
You realize just how horrible you are?
I am. I'm a horrible human being. Take a look at what you have here. You wind up with same variables on, or same things on both sides, cotangents on both sides, so pick on the little guy. So I'm going to move the -2 cotangent theta over to the left. At the same time, I'm going to add 1 to the other side. You okay with that? So I'm going to add 2 cotangent theta to this, so I get 4 cotangent theta is 0. Divide both sides by 4, and what theta value has a cotangent of 0? In order to get a cotangent value of 0, that means it has to be on a quadrantal. It's the only way you're going to get zeros for these. So when you're working with cotangent, well, remember you have 1, 0, 0, 1, -1, 0, and 0, -1. Cotangent is the inverse of tangent. Tangent is sine over cosine. Cotangent is cosine over sine. So I'm looking for a cosine divided by a sine. I'm looking for an x divided by a y that equals 0. That means y cannot be 0. So where is y 1 or negative?
Pi over 2 and 3.
At 90, so my answer here is going to be a pi over 2
Hey, it says radians.
and 3 pi over 2. Those are going to be my answers. Now, that would be my solution within one ringy-dingy. If it was a general solution, what would it look like?
Oh.
Plus 2 pi n.
Would I have to do plus 2 pi n for both of these? This would just be a plus pi n because it's going to oscillate between pi over 2 to 3 pi over 2 each section. Okay? So just remember that that's the only
So for
difference.
general, you just have the 2 pi n or pi n.
Yeah. It's the only difference. Okay? Yeah, easy.
Okay, I describe it as higher thing, but like, do you remember when we were doing this, and I feel like sine could only be on like one half of it, so you didn't have to worry about that.
Sine was
Cosine
like-
would be like on the top, and on part of it, something like that.
That was, yeah, that was
What
the,
that for?
that was the same basic stuff. That was, here, I'll pull a question up from that. I don't remember what section that was. I think it was 14.4.
Yeah, it was,
Isn't that like the graph?
Was it 14? I think it was 14. Was it 14.4?
I remember learning it, but I don't remember. If sine was everything
Yeah, it's something like this, where you have, when you start looking for it, oh, I know what you're thinking of. You're thinking of, that was 13, oh, what section? 13.4, 13.4, that's the inverse. Okay. In 13.4, that's when you were doing this. Okay. You were asking about what angle has a sine value of root 2 over 2. That's what you're asking.
Yeah, maybe.
So when it's asking you to find the angle that has this, this is when, obviously, when you're just trying to find a singular angle, it's asking you to do that. That's when you're looking at the sine values are positive between here and here. So which quadrant would give me a positive root 2 over 2? First quadrant. So according to that, which angle has the root 2 over 2? So my answer would be pi over 4. That's what you're asking about. That's when you're doing these types, when you're just looking for the singular angle. Okay. Another one, for if I have cosine I just looked at it too. Negative root 3 over 2. Okay. Cosine first second. Cosine's negative second quadrant. Root 3 over 2, we had a reference angle of what? Well, I'm looking at cosine to get a root 3 over 2. That's my 30-degree angle there.
But then you have to.
Slamming it into the second quadrant, which means the reference angle comes up 30 degrees, so it's 150. So it comes up pi over 6. So it's, what is that, 5 pi over 6?
Wasn't like tangent where like you could use the quadrant? So you can't use the quadrant.
You can't use the quadrant as a tangent because you can't divide by 0.
Okay, I just.
That's why it's not, it's the same thing as sine, but it's non-inclusive on the quadrantal.
Like, one of the reasons my examples is cosine of 2, and then it's just
Correct, because is cosine ever going to be greater than 1? No, and that's why. You'll never have a cosine value.
Between 0 and pi.
Yep. Well, that's the angle values, okay? It's saying what angle has a cosine value of 2. The angle, you'll never get a value of cosine that's greater than 1, because think about your unit circle. What's the largest value on the unit circle?
2 pi.
1. You're thinking the radius is 1. Each of these ordered pairs just comes up with different ordered pairs coming across here. But the largest value is only 1.
So
You
nothing
can't-
can be over 2 or over 1?
Correct.
Okay. Can it be 1?
Yeah. Who has a cosine of 1?
Tangent. So, I don't know what you're asking.
What angle has a cosine value of 1?
Zero.
Where's cosine equal to 1?
180.
Oh, 0.
0. It's at 180 if it was negative 1.
There's negative one.
Right.
Okay,
Okay, that's what that is. Okay. Let's go into another equation one. If I go back to the other 14 one on this one, with the little chapter test stuff. I think we had, yeah. Let's see, let's do number 15. It's a general solution. 3 sine of x is sine of x plus 1. And I'm going to find the general solution of that. General solution is when you have to tack on the repetitions.
Oh, yeah.
I'm going to subtract sine of x, and I'm going to get 2 sine.
So sine of x equals 1/2.
Yeah, sine of x equals 1/2. And now, this is when you're asking yourself, what angle has a sine value of 1/2? It's going to be
Wait, wouldn't it be 30?
Yeah. 30.
Damn.
So I'm looking at this here. It's going to be first quadrant coming up. 30 was, yeah, so it's 30 degrees, so it's going to be at pi over 6. But what other quadrant is sine positive?
Quadrant 3.
2. Sine's positive over here, so that value comes up pi over 6, so it's at 5 pi over 6.
And this is where you have to do the 2 pi n.
Correct. These guys aren't equidistant from one another. So you have to tack on plus 2 pi n. Okay. The ones that wind up being equidistant are generally tangent because they're opposite, they're off by just pi. Or if you wind up with a 45 into all 4 quadrants, it's really the only time you wind up with something less than 2 pi. Graph-wise, wow, we're just running short here, aren't we?
Yeah, this one.
Remember, you do have, we'll probably have to spend more time on trig tomorrow,
That's okay.
which is fine. What's that? I was going to try and do some of the most recent stuff, you know, probability and matrices, and so, I was trying to bring in some of that modeling. That wasn't tough. So modeling was a lot of calculator. I'm going to remind you guys how you put stuff in there for regressions and things like that. But it'll say it's such has a regression type thing, and you just have to know the button to press. Yes, ma'am.
Are you like recording these?
Yeah. If I go into the graph one, if I'm back to this, just remember. If I go to graph something like that,
Wait, where is this?
this is on this one, Phoebe, it's number 3 on the test C.
Oh.
Think about what they're going to ask you to do on a multiple choice test. Probably a lot of period and amplitude, because you can graph this in your calculator. We just never did. If you're going to graph this in your calculator, if you graph that in your calculator, you got to make sure you are in radian. You put the calculator in radian, it should come out where you can do that. Then you can adjust your window. If you know how to adjust your window to find your period and your amplitude, you should be all right. Remembering how to find period. Period is going to be 2 pi over b, the absolute value of b. Whereas in tangent, it's pi over b. That's where you get your asymptotes. There's a lot of trig. Well, I would say a lot, and there's lots of fun stuff.
I
And that's just fun when people are,